Okay, exponential functions today, guys. We're going to combine exponential functions with what we learned about geometric sequences. We're going to kind of do it all in one here. When we were on this unit, we talked about a few different formulas. The first one that we're going to talk about right now is this y equals a times b to the power of x. Remember, if your calculator does a regression, this is the one that your calculator gives you. All right, just a quick refresher. All right, so in this first one, we're just going to talk about whether or not it's growth or decay and different kind of parts of the graph here really quickly, okay? So if you will please remember, the number in the front is your y-intercept, all right? So my y-intercept is 3/5, and then the number inside is your growth factor or your decay factor. All right, so since this is bigger than 1, we're going to say my growth rate is 8. Okay, and guys, it's important that you know this is growth, right? It's growth, right? Because b is greater than 1. The next example is very, very similar, right? My y-intercept, the number in the front, is just going to be 3. Sorry, that should probably say y-intercept is 3. All right, so we've got that the y-intercept is 3, right? That's just because this is the number in the front. Now this is a number not greater than 1, right? This is a number smaller than 1, between 0 and 1. So we're going to call this not my growth rate, we're going to call this decay, right? This is my decay rate because we've got a number between 0 and 1, right? We've got a fraction, which is why this is decay instead of growth. All right, so make sure you know this is decay because it's a fraction in the parentheses, and this is growth because I've got a number greater than 1 in the parentheses, right, my b values. Over on the right, we've got some actual word problems here, and you'll notice that we also have a different formula. This time we've got y equals a times 1 plus or minus r to the power of x. You will use this formula when you are given a percentage. If you're given an actual percentage, this is the formula that you want. Okay, so for example 3, it says the population of a town is growing by 5% each year. Just before we go any further, please recall that 5% is the same as, move that decimal twice, 0.05. Okay, so if I'm going to write an equation for the town after X years with an initial population of 21,000, and if y'all remember, A is my initial amount, then all I'm doing is plugging numbers into this formula. All right, so I've got y equals, my initial amount is 21,000. I've got the parentheses, I've got 1. Now I need to decide between a plus or a minus. Okay, and the way that you do that is just by reading that problem. This problem is talking about something growing, right, which is why I'm going to choose to use a plus sign. All right, and my plus sign is going to be plus r. We talked about r being 0.05, again, just to the power of x. This is just an equation. The next problem is very similar, right? We've got a value of $55,000. It's a car that's depreciating at a rate of 7.8% each year, and we need to write an expression. Okay, 7.8%. 1, 2, means we're using 0.078 in our equation. So we're going to have y equals the initial amount, 55,000, parentheses, 1, and now I need to decide between a plus or a minus, but this time when I read the problem, right, we notice that this one says depreciates. Hopefully you guys know that that sounds kind of like decay, right? That means that we're losing value, so I am choosing to use a minus sign. And then we've got my rate, which you said was 0.078 to the power of x. All right, and that is my formula. The last thing that I want to remind you guys about are geometric sequences. And this is our last formula on the exponential unit, right? Remember that a sub 1 just means the first term, right? The initial amount, kind of. And then r, this is called our common ratio. That's an A. All right, common ratio. Basically, that's just what you're multiplying by. Okay? All right, so in example 5, it says, given this geometric sequence, write the rule. It just means write the formula, right, for the nth term of the sequence. So we know we start with a sub n. It's kind of like a special way to write y equals for sequences. A sub 1 is the first term. Well, the first term is negative 5. We need to figure out r, and we're going to have it to the power of n minus 1. Okay, well, what are we multiplying by? This one should be fairly easy. What am I multiplying to get from negative 5 to 10? That's times negative 2. Keep checking. Is 10 times negative 2 negative 20? Yes. Is negative 20 times negative 2 positive 40? Yep. And then is positive 40 times negative 2 negative 80? It checks out, right? So my value for r is going to be negative 2. This is my answer, right? This is my rule. This is my formula. Last but not least here, what are the first three terms of the sequence whose nth term is a sub n equals 7 to the power of n minus 1? Basically, guys, you are given the formula, and you have to find the terms. So why don't we kind of set up like little numbers right here. So like the first term, the second term, the third term. Let's figure out what these terms are. Okay, well, if it's the first term, then the n value is 1. So I'm going to plug 1 for n. So 7 to the power of 1 minus 1. Okay, well, that's 7 to the power of 0. And 7 to the power of 0 is just 1. All right, so that's my first term. We're going to do the same thing now, but now our n value is going to be 2. So 7 to the power of 2 minus 1. Okay, well, that's like saying 7 to the first power, which is just 7. Okay, last but not least, we're going to use 3 for n. So 7 to the power of 3 minus 1. It's like saying 7 squared, which we know is 49. So the first three terms for the sequence are going to be 1, 7, 49. And that's our answer. Okay? All right, answer the questions in this video and then go to work on your quizzes.